LHS Pre-Calculus presents Bum 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 Complex Numbers.
Welcome to Simply Complex Numbers. Now your fantasies will become reality and your reality's fantasy.
Have you ever tried to solve a problem and had a negative number under the radical? Do you not know what to do because you know you can't take the square root of a negative number? Well, there's a solution.
To solve a problem where x equals the square root of -1, mathematicians created an expanded system of numbers using the imaginary unit I. They decided that the square root of -1 would be equal to I.
Now, if I is equal to the square root of -1, then I squared is equal to the square root of -1 times the square root of -1, which equals -1. Following suit, I cubed is just I squared times I. So if I squared equals -1, then I cubed is equal to -I. Similarly, I to the fourth is the same as I squared times I squared. And if I squared equals -1, then I to the fourth equals -1. And then I to the fourth will be the same as I squared times I squared, or 1.
Now luckily there's a pattern that develops here. Since I to the 0th power is 1 and I to the 4th is 1, a pattern repeats every 4 powers of I. So if you want to quickly find the value of, say, I to the 77th power, you divide 77 by 4, 19.25, and the way you would find the value of I would be to apply your decimal portion to the n divided by 4 scale.
Now this is getting a little complicated, so I think we need some diagrams here. Here we have a Komodo dragon. Think of it as a real number. And here we have the square root of -1, also known as I. Normally these two wouldn't get along, but with this new math concept, when you multiply this Komodo dragon by I, we get a dragon, which is an imaginary animal. Here we have a horse. When you multiply a horse by something real, I, you get a unicorn, something imaginary.
Alright. Now things are going to get a bit more complicated. In many situations you'll have real numbers, and the numbers that can be put on a number line, an imaginary term, I, in the same term. We call these numbers complex numbers. The standard form of complex number is a plus bi, where a and b are real numbers, and I is used as an imaginary unit that we discussed earlier.
Now that we know what complex numbers are, we can demonstrate how to add and subtract them from each other. When you add and subtract complex numbers, all you have to do is combine like terms. So in the addition problem, the real terms 1 and 5 would be added together and yield 6. The imaginary terms 6i and 9i would yield 15. In subtraction, you do the same thing, but instead of adding them, you subtract them. So you take the real numbers 2 and 7, and 2 minus 7 equals -5. The imaginary terms 6i and 9i, when subtracted, will equal -3i.
Now that the basics of adding and subtracting complex numbers are over, we can multiply and divide them as well. Multiplying is easy, since it will involve at least two separate terms and can be solved by foiling. Here we have 1 plus 4i squared, which is 1 plus 4i times 1 plus 4i. To solve this problem, we are going to FOIL and combine like terms. Foiling, we get 1 plus 8i plus 16i squared, which is 1 plus 8i plus 16 times -1, since I squared is equal to -1. Combining like terms, we get -15 plus 8i as your answer.
While dividing, however, things get a bit more tricky, since you end up multiplying the entire equation by the complex conjugate number. A complex conjugate number is a complex number that can be multiplied to another number to make a real number. So if a complex